What is fluid mechanics? Fluid mechanics is a branch of physics concerned with the mechanics of fluids and the forces on them. Basically, it studies the fluids. Now, what is fluid? In physics, a fluid is a substance that continually deforms or flows under an applied shear stress or external force. Fluids are a phase of matter which includes liquids, gases, and plasmas. Few of the examples are water, blood, mercury, honey, gasoline, or any other gases and liquids that surrounds us. Here in fluid mechanics, you are bound to know the fundamental concepts of the fluids that covers the properties of it, which are the intensive properties and the extensive properties. Intensive properties do not depend on the quantity of matter. Few of the examples are boiling point, color, temperature, luster, hardness, and even density. On the other side, extensive properties do depend on sample size. Examples include are volume, mass, size, weight, and length. Fluid mechanics can be divided into two branches, the fluid statics, or the study of the fluids at rest, and the fluid dynamics, which is the study of the effect of forces on fluid motion. Fluid statics is the branch of fluid mechanics that studies incompressible fluids at rest. It encompasses the study of the conditions under which fluids are at rest in stable equilibrium as opposed to fluid dynamics, the study of the fluids in motion. Fluid statics can be fundamental to hydraulics, the engineering of equipment for storing, transporting, and using liquids. It is also relevant to geophysics and astrophysics, for example, in understanding plate tectonics and the anomalies of the Earth's gravitational field, to meteorology, to medicine, and many other fields. On the other side, fluid dynamics is a branch of applied science that is concerned with the movement of liquids and gases. The movement of liquids and gases is generally referred to as a flow, a concept that describes how fluids behave and how they interact with the surrounding environment. For example, water moving through a channel or pipe. Flows can be either laminar or turbulent. Laminar flows are smoother, while turbulent flows are more chaotic. The study of the liquid flow is called hydrodynamics, which liquids include all sorts of substances, such as oil and any other chemical solution. By far the most common liquid is water. Hydrodynamics' most common applications includes flood control, operation of city water, and even sewer systems. On the other side, the study of the gas flow is called aerodynamics, which is the dynamics of bodies moving relative to gases, especially the interaction of moving objects with the atmosphere. Problems in this field involve reducing drags on automobile bodies, designing more efficient aircraft and wind turbines, and even studying how birds and insects fly. In dealing with fluid mechanics, you are bound to encounter and learn its lessons such as pressure at point within a fluid, equation for a pressure field, manometry or the measurement of pressure, force on an immersed surfaces, buoyancy, and stability. Fluid mechanics concepts are used diversely in our day-to-day life. The principles are used on simple things to rocket science. It has applications in a wide range of disciplines including mechanical, civil, chemical, and biomedical engineering, geophysics, oceanography, meteorology, astrophysics, and biology.